I'm going to start with the littlest and work to the biggest. We are limited to a point with an impact sprinkler. And in fact, here's the smallest style they make. It's called a 20 series. And the concept between an impact, you can see the concept. See that drive? That's how it turns. It's by the impact of the arm. Now the arm doesn't get all the way over and smash that plate. What happens is a stream of water is coming out this nozzle. That water is shooting out that nozzle. This arm comes over, intercepts the nozzle, and the water hits the backside of the cup in the arm and drives it back open. So it comes over, and then it slams back into the stream, and it makes it move again because it drives that way and then gets thrown back out of the way, drives and gets thrown back out of the way, drives and gets thrown back out of the way. So a spring tension creates the force, and what you're doing is you're reloading the spring every time the arm makes a stroke. And what causes the arm to get driven out is actual water pressure hitting the arm and hitting into the cup of the arm and driving it back open. So water comes in. I think I have an arm here. Water comes through here, through this cut edge, hits this back side of the arm, and when it hits that cup, the water wants to deflect out that way. The arm wants to deflect back this way. So it causes the arm to kick back sideways because of the water hitting up into the cup of the arm. Pass that around. And then we're relying on the spring tension, and it has to be set at the right tension. So if you go to a sprinkler manufacturer, they actually test every sprinkler head that comes out and make sure that this spring has the right amount of tension on it so that that arm doesn't go too far or not far enough. It has to have the right amount of drive so that it keeps driving every time. If it goes too far, it'll actually hit the backside of the sprinkler itself and drive. It can actually make it drive backwards if the spring tension's set wrong or if the pressures are way off. So we have a spring. Don't destroy that spring, but I'll pass it around and you can see that there's quite a bit of tension on that spring. Different size bases on these. This happens to be a 1/2 inch. And a 1/2 inch sprinkler is going to have a relatively small flow through it because we've restricted it due to the size that we've given it. And we put a nozzle on here that's going to produce somewhere, probably the low end, about 1 gallon a minute. The upper end, maybe 6 gallons a minute out of a 1/2 inch drive sprinkler. So 20 series. These will be impacts. We could have the base will be 1/2 inch. The flow somewhere 1 to 6 GPM. In fact, these will all be GPM. And the pressure, and this will all be PSI. Generally, these things will not drive with less than about 20 to 25 PSI. You can get them that'll drive at 20 and no more than 50. And 50 might be too high for a lot of them. That'll be the extreme ranges. You know, they're going to work best around 35 to 40 PSI. Generally, these things will work best right in the heart of their rating. Same with the flow rates. You know, the most economical is probably about in the middle, around 3 gallons a minute or so. This one has a little extended top on it because it fits down in a canister. It's a turf type, but this style could be used in an orchard. And we'll talk about some of the other aspects of these later on in the discussion. We can have different angles of trajectory as well. We can shoot this thing out really low if we're doing this under trees in an orchard. We can keep it really flat. Maybe just a few degrees, 5 degrees, 6 degrees. Normally we want to have that trajectory around somewhere between 20 and 25 degrees. 23 degrees, 24 degrees is pretty normal. That gives you maximum range. Range meaning how far the water will throw. You know, it's like out there in watching these war movies, they'll shoot these mortars. And you can shoot a mortar and they'll keep going further and further as you up elevate. But if you get it too steep, what happens? Then it starts falling short again, doesn't it? Until it comes straight up. You aim it straight up, it's going to come straight down on you. Well, the point of greatest range happens to be around 24 degrees, where you get the maximum trajectory to get the furthest throw. And so we usually look at a sprinkler to maximize the throw that it gives us. The throw is called the range, how far it ranges out from the head itself. That angle is not the best angle if you're trying to water underneath a crop. So in an orchard, under a tree, all of a sudden you're trying to minimize hitting up into the limbs. You're trying to drive it under the limbs. So all of a sudden that whole concept of how far it throws isn't as important as trying to get it under the limbs so that you get water distributed evenly out underneath the crop. And then there's also the concept of, in real windy areas, we want to drop that down to maybe 15 degrees or 16 degrees to reduce the effect of the wind on that particular sprinkler. By dropping it, by getting it up high, you get affected by more wind. Right down on the ground, the wind will have its minimum velocity. By the time you get about 12 feet up in the air, you're getting up to the velocities that are going to be way, way faster than you have down close to the ground. And lots of weather data has been taken. We can see the results of maybe a 2-mile-an-hour wind at a foot off the ground can be a 12-mile-an-hour wind at 10 feet off the ground. That's the kind of effect you'll have, the difference in the effect. So where we do have windy conditions, we want to lower that trajectory of that sprinkler so that we have less interference with the wind.